Hello students, let's try to understand the factor affecting electric resistance. This we have to understand in this video. Okay, student, there are four factors that affect the resistance of a wire. Okay, what is this factor? Resistance is proportional to length. So that is R proportional to length, that you know. If you take a wire of different length and give each a particular potential difference across it in, the longer the wire, less volt each centimeter of it will be, means voltage will decrease. If the length of the wire will be large, so that potential if the length of the wire will be large, the potential will be less. This means that the electric slope that makes the electrons move gets less steep as the wire gets longer. That's okay. And the average drift velocity of electron decreases. That is also okay. Means that is the you think, student, that is if the length increases, so the potential voltage decreases. This is the inversely proportional, student. The correct term for the electric slope is the slope gradient. A smaller potential gradient, less volts per meter, means that current decreases with increase in length. That is what the point is, student. Current decreases with increase in length. That is resistance increases. Now go for the another one. Resistance is inversely proportional to the area of cross section. This is point number 2. Second factor. The bigger the cross section, they are saying that is resistance inversely proportional to what? Area of cross section. Bigger the cross section area of the wire, greater the number of electrons that experience the electric slope from the potential difference. As the length of the wire does not change, each centimeter still get the same number of the volts across it. The potential gradient does not change, and so the average drift velocity of individual electron does not change. Although they do not move any faster, there are more of them moving, so the total charge movement in given time is greater than the current flow increases. This means the resistance decreases. This does not give rise to a straight line graph, as cross section area is inversely proportional to the resistance, and no resistance not directly proportional to it. So it is the resistance is inversely proportional to area of cross section. Now go for the third factor. Resistance depends on the material of the wire is made. The more tightly an atom holds onto its outermost electron, the harder it will be make a current flow. The electronic configuration of an atom determine how willing the atom will be to allow an electrons to leave and wander through the lattice. If a cell is almost full, the atom is reluctant to let itself electron wander, and the material it is in the insulator. If the outermost cell or the subcell with the tension metal is less than the half filled, then the atom is willing to let those electrons wander and the material is a conductor. Now fourth factor. Resistance increases with the temperature of the wire. The hotter wire has longer resistance because of increased vibration of the atomic lattice. When a material gets hotter, the atoms in a lattice vibrate more. This makes it difficult for the electron to move without interaction with an atom and increase resistance. The relationship between resistance and temperature is not simple. This is what. So this is all about the answer, student. Thank you so much for watching.